So right now I'm writing about prostaglandins, and I definitely made sure that I made it very simplified by showing you the principles of duality of life versus death. And I wanted you to see what antibodies were because they are antibody. And I want you to see what prostaglandins are. And prostaglandins are actually, of course, they're part of the immune system, and they do control the antibody replication and antibody programming or antigen programming. Okay, so we're getting into some really technical stuff, and that's why writing is so important because it slows your brain down to be able to break things down to its most infinitesimal state and then be able to explain it and articulate without oversimplifying. But I want to oversimplify in a lot of ways so that way you get it on a bigger picture, and then I can explain how the bigger picture has been what it's comprised of. Okay, so as I'm writing about these principles of duality and I'm writing about prostaglandins, I realized that actually prostaglandins also can induce antibody replication. That's part of the inflammation process. But simultaneously during that inflammation process where you have antibodies that are being replicated and induced and going after the bad tissue and triggering a peptocyst and autophagy and all of that, there's also the life side of the prostaglandins, which are like the EF2. And let me tell you what some of these prostaglandins do. And this is what biotech does. They turn on and off different hormones. And that is the different prostaglandins within your immune system. That's what immunology is. It's the study of how they turn on and off the hormones of prostaglandins and what they want to express and what they want to constrict, I would say. Okay, so let's take a look at these prostaglandins, different types of prostaglandins, because this is what, I went to this website called You and Your Hormones and Prostaglandins, and this is their lead-in is the prostaglandins are a group of lipids made at sites of tissue damage or infection that are involved in dealing with injury and illness. They control processes such as inflammation, blood flow, the formation of blood clots, and the induction of labor. Okay? And then alternative names for prostaglandins. And this is what had me realize there's several different types of prostaglandins. Okay? There's prostaglandin D2, prostaglandin E2, prostaglandin F2, prostaglandin I2, which is also known as prostacyclin, which is a closely related lipid called thromboxane. And that actually is a vasodilator, which opens up your blood vessels. It does not allow the coagulation of your blood vessels or the blood cells. Okay, it actually allows blood to move freely through your body. Okay, so what else do they say in here? What are prostaglandins? Unlike most hormones, which are produced by glands and transported in the bloodstream to act on distant areas of the body, the prostaglandins are produced at the site where they are needed. Prostaglandins are produced in nearly all cells and are part of the body's way of dealing with injury and illness. Prostaglandins act as signals to control several different processes depending on the part of the body in which they are made. Prostaglandins are made at sites of tissue damage or infection where they cause inflammation, pain, and fever as part of the healing process. Okay? So when you're dealing with some kind of damaged tissue, it's out with the old, in with the new type of scenario. When a blood vessel is injured, a prostaglandin called thromboxane stimulates the formation of a blood clot to try to heal the damage. It also causes the muscle in the blood vessel to contract, causing blood vessels to narrow to try to prevent blood loss. Okay? Another prostaglandin called prostacyclin has the opposite effect to thromboxane, reducing blood clotting and removing any clots that are no longer needed. It also causes the muscles in the blood vessel wall to relax so that vessel dilates. The opposing effects that thromboxane and prostaglandin have on the width of blood vessels can control the amount of blood flow and regulate response to injury and inflammation. So you see how they are trying to control even how your prostaglandins control the blood flow, expanding, contracting, reducing blood clotting, inducing blood clotting. Okay? And so this is why when you're taking anti-inflammatories, you're basically shutting off the body's ability to intelligently figure out what it needs to do at any given moment in time during illness and injury. That's why I say you guys are experiencing the depopulation at the micro level because of the drugs that you're taking, the anti-inflammatories that you're taking, and all the different detoxes and prescription drugs and over-the-counter drugs. And this is why you have now diversity in the population, why all of you are, or not all of you, but a lot of you are drug dependent. Whether it's insulin, whether it's, all the different diabetic medications, whether it's painkillers. Okay? And so then I looked up all the different prostaglandin names. This is so interesting. Oh my God. So then I look at, prostaglandin D2. So prostaglandin E2, which is what I posted on my Facebook, which has to do with muscle cell regeneration, then prostaglandin D2 holds the cure to male pattern baldness. So somehow, somewhere, somebody in your genetic line had turned off the prostaglandin D2, and so balding is then in people's genetics. And then what do they have? What does pharmaceuticals have? They have some kind of pharmaceutical that will induce the prostaglandin D2 to express itself, and then, oh wow, now you have hair. Oh, fancy that. Okay, so prostaglandin D2 holds the cure to male pattern baldness. But what would happen if something in your body wasn't constricting that prostaglandin or stopping it from producing? Or what would happen if you actually were able to turn that gene on or turn that hormone on your own with the right chemistry? Not through biotech, but through cabbage water and cabbage water and white salt. Okay? So that's prostaglandin D2, which has to do with male pattern baldness. And if you express that, then you're able to grow your hair. Oh my God. So prostaglandin D2 has recently been identified as a factor which is elevated in the bald scalp of men. So prostaglandin D2 is a prostaglandin that binds to receptors, as well as CR whatever, is a major prostaglandin produced by mast cells, recruits Th2 cells. Okay? And anyways, so does prostaglandin D2 hold a cure to male pattern baldness? Well, of course. Which is elevated in the bald... hold on a second. Oh my God, trying to figure this shit out. Okay. Give me 1 second. I'm in the process of research, okay? So I may have to retract what I said about male pattern baldness in this. Lipids in the skin are the most diverse in the entire human body. They're bioactive in health and disease. And underexplored prostaglandin has been recently identified as a factor which is elevated in the bald scalp with bald scalp. Okay. And has capacity to decrease hair. Oh, okay. So too much prostaglandin D2 has created, too much prostaglandin D2 has created the bald scalp. So prostaglandin D2 has recently been identified as a factor which is elevated in the bald scalp of men with androgenetic alopecia and has the capacity to decrease hair lengthening. An enzyme which synthesizes it prostaglandin D2 synthase, is a hormone responsive in multiple other organs, has 2 known receptors, and was found to be necessary for the decrease in hair growth by PGD2. Oh, so what they're trying to do is inhibit the growth. Okay. See, and this is the thing. Why is it that you have elevated levels of prostaglandin D2? Because there is an imbalance in your biochemistry that's causing now more of that enzyme to be produced, which then affects your hair. Okay? So prostaglandin D2, when it's too much of it, now you have balding. So, and this is the thing, is that supposed to happen? Is balding supposed to happen? Is that the natural order, of humans as far as our evolution? And we're all supposed to have hair as a protection to our head, to our scalp. Okay, it's not because it's used to do fashion and that's what, the architects of our universe, oh yeah, we got to have hair so you can braid it and do all these crazy things to it. No, every single hair and every single thing that goes on your body, there's a specific reasoning for it. And yeah, there is part of also crossbreeding and all the different, bio stuff that goes bioengineering, but we're supposed to have some kind of hair on our head. Okay? So too many prostaglandins then creates too much baldness type of thing. Okay, well, I'm glad I looked that up because I had the total opposite expectation. And so prostaglandin E2 and cyclooxygenase 2. So prostaglandin E2, PGE2, is a potent inflammatory mediator that is generated by cyclooxygenase 2, COX2, conversion of arachidonic acid, PGE2, supports tumor growth by promoting angiogenesis, stimulating tumor cell proliferation, and protecting tumor cells from apoptosis. So this is when you have so much prostaglandin, which then will incur tumor growth, which is basically evolution. Okay? But you have to be able to release the excess, or else you have then all of this life being replicated, but it's not being distributed correctly. And so, yeah, this is where you have tumor cell proliferation because, yes, the body is trying to evolve and you're not releasing the excess. And then, yes, you have these different growths on your body. And then this is when people start getting things lanced off. Okay? Because prostaglandin is all about life. It's pro-life. It's creating life. Even though it's not really working with you right now in your state of your being today, it's still replicating. It's still trying to promote life. It's not destroying you. It's trying to promote life. But why is there a tumor growth? Because the body is trying to evolve and you're trying to stagnate it and it's trying to, live. And then, oh my God, there's this whole conflict. And so, yeah, that's why people have tumors, is because the body is trying to evolve and you're not allowing it to release the excess. And then you're allowing it to also try to live. And it's just like watching a flower work its way through the cracks in the cement. You cannot stop life from trying to live. And that's what prostaglandins are. They are the key forms to life, but it has to be able to do it correctly, and you have to be able to allow it to distribute correctly. And that's what's going on, is you're having so many different life forms trying to live, and then you're not balancing all those life forms together. Okay? So prostaglandin F2 alpha, what is that? Prostaglandin F2 alpha, pharmaceutically termed carbopros, is a naturally occurring prostaglandin oxytocin, which is all that pleasure y'all chasing after when you're all about love, 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 and sex, sex, sex. Oh, let's chase the oxytocin. So prostaglandin F2A alpha, pharmaceutically termed carbopros, is a naturally occurring prostaglandin, oxytocin-associated neurophysin concentrations in the utero-ovarian vein of pregnant and non-pregnant people. So this is what you guys are chasing after when you're trying to express your oxytocin. It's within the prostaglandins. Okay? So interesting. Wow. Prostaglandin F2 alpha, one of the prostaglandins, a group of hormones-like substances that participate in a wide range of body functions such as the contraction and relaxation of smooth muscle, the dilation and constriction of blood vessels, control of blood pressure, and modulation of inflammation. Okay? So that's probably why, when you guys have your moment, your O face, the dilation and constriction of blood vessels and all of that, and relaxation of smooth muscle and all. So, this is so cool. Oh my God. I'm like totally fascinated. All right. Then prostaglandin I2, prostacyclin. Prostacyclin is a prostaglandin member of the icosanoid family of the lipid molecules. It inhibits platelet activation, and it is also an effective vasodilator. It expands your blood vessels. When used as a drug, it is also known as epoprostenol. The terms are sometimes used interchangeably. So it's a powerful vasodilator, okay? It opens up your blood vessels. And then I looked up like B cells and T cells and lymphocytes because I simplified again because I want to make sure you guys understand how this kind of works. You can turn things on and off and things can get activated. They can get programmed and activated and induce, different antibodies that will go and do a search and destroy, like SpyBot search and destroy, like on your computer. So, T cells, thymus cells, and B cells, bone marrow or bursa-derived cells, are the major cellular components of the adaptive immune response. T cells are involved in cell-mediated immunity, which is like death, whereas B cells are primarily responsible for humoral immunity, which is death, relating to antibodies. So T cells are how things are being programmed. Okay, so when you are adapting to something, you are programmed, because adaptation is programming. When you adapt to a family, you are programmed now to live that way of the family, whatever that family is. Okay, so that's a programming. So when you're adapting to an environment, you are now programmed to be able to handle and align with that environment. That's the T. That's the T cells and B cells are major. Okay, adaptive immune response. T cells are involved in cell-mediated immunity, whereas B cells are primarily, okay, and it's all, okay, so T cells and B cells are part of the adaptive. So they're both antibody related, but they have specific jobs. So T cells are involved in cell-mediated immunity, whereas B cells are responsible for humoral immunity relating to antibodies. So B cells are antibodies, T cells. Thymus. Okay, I'm going to have to go do more research on that. So there's a lot more I know I have to do. Okay? But anyways, but understand that the prostaglandins have the control over antibodies, and prostaglandins can give you life or they can cause you death. And it's all about what is being expressed within prostaglandins. Antibodies are just a component of the prostaglandins, and there are the cell regeneration part of the prostaglandins, and prostaglandins are the key to life and death. Okay? And it's still the principles of duality. It's still, yin and yang. Because of what is being expressed, how much or how little. Antibodies are antibody. So that is never ever going to change. It's the type of programming to these antibodies what is differentiating between the B cells and the T cells. So it gets very, very technical, but I have the art of knowing how to simplify things so you can kind of get it on a very superficial level. But then when it gets down to the nitty-gritty is where I have to go and really just pick apart all of these, so that way the left brain people can understand where I'm coming from, and then the right brain people can also understand where I'm coming from. Okay? Big picture and small picture people can need to understand where I'm coming from. All right, bye. Interesting.